Hello gentlemen, welcome to our video lecture on sections 1.3 entitled Solutions, Suspensions, and Colloids. Now back in section 1 you were introduced to what matter was, or what matter is. And matter was separated into two major categories, pure substances and mixtures. When we talked about pure substances, we said pure substances were elements and compounds, and they were only one kind of particle throughout, meaning all one element, all one compound. The other side of matter mixtures. And this section deals with what a mixture is and the different types of mixtures that exist out there. Now, a mixture is a physical blend of two or more substances. The key of this definition is that it's a physical blend. There's no chemical reactions happening. You're simply just putting two things together and manually or physically mixing them together. Now, mixtures can be separated into two major categories, homogeneous mixtures and heterogeneous mixtures. On this board, and in half of the next board, I'm going to deal with homogeneous mixtures. Heterogeneous mixtures will be on the half of the next board, so we'll hold tight on that one. So let's review what a homogeneous mixture is. Homogeneous mixtures are mixtures that are uniform throughout, and all parts of that mixture look the same to the naked eye. And substances that make up this mixture are evenly distributed throughout. In class, we did an example in our investigation using salt and sodium chloride, salt, which is sodium chloride, and water, which is H2O. And we mixed those together in NaCl and H2O, we created a homogeneous mixture. You could see clearly right through everything. One part of the mixture didn't look different from the other. I couldn't point out, hey, well, there's the salt, and well, there's the water over there. You couldn't do that. Everything looked uniform in nature. That is an example of a homogeneous mixture. Now, within the category of homogeneous mixtures, we can classify different mixtures even more. So, a certain type of homogeneous mixture is called a solution. These are going to be very important for us throughout this year. A solution has two parts. The first part of a solution is called the solute. And the solute is the dissolved particles in your mixture. And this usually, or by definition it is, present in the smaller quantity. So it's the particles that are present in the smaller quantity. In this case, it would be our NaCl. Add a small amount of salt and a large amount of water. That salt is called my solute in this case. The solute is the chemically active portion of the mixture. That's usually what you're really interested in. The second part of a solution is my solvent. The solvent is a substance that is present in the larger amount. In the case of my example with salt, water, the solvent was H2O, the water. So I had a small amount of solute, which was my NaCl, my salt, and I had a larger amount of solvent, which was my water. Generally, and usually, the solute dissolves in the solvent for this particular type of homogeneous mixture called a solution. Now, solutions with their two parts, the solute or the solvent, can come in different ways. They can be solids, liquids, or gases. So a solute can be a solid, liquid, or gas. A solvent can be a solid, liquid, or gas. And the particles in a solution are very small. Very small. That's why we couldn't distinguish there's a salt from there's, to the water. Now, another type of homogeneous mixture is called a colloid. Now, a colloid falls within the homogeneous mixture family, but there are some differences between a colloid and, let's say, a solution. The particles are dispersed and they are larger than those in a solution for the colloid. But they're still uniformly distributed throughout the mixture, making it still fall within the homogeneous mixture family. So colloids have larger particles than solutions. An example of a colloid is milk and H2O. So in this mixture, the milk molecules are still suspended within the solvent, which in this case we'll say is water. But those particles are much larger. And then being much larger gives them a slight I guess, a different characteristic than a solution. And we can identify colloids by this point down here. We can identify colloids by observing how much light is scattered through that colloidal mixture. So if I were to take that milk and water mixture, if I physically made it, and shined a light through it, the light would scatter through the colloid, meaning it wouldn't pass straight through as a beam of light. It would scatter everywhere, and we wouldn't see it pass right through that mixture. However, if I did that with a solution, let's say salt water, if I pointed a laser light or a light right at that solution, it would pass right through and hit the wall behind it. And the reason it passes through is because the particles are so small. But in a colloid, the particles are much larger, so when the light hits those particles, it scatters. Now, this process of scattering light is called the Tyndall effect. So we use the Tyndall effect to verify that we do have a colloid, seeing that light scatters. So those are the different types of homogeneous mixtures. Read up on them, see where they're similar, see where they're different. Now the other type of mixture is a heterogeneous mixture. So in a heterogeneous mixture, it's a mixture that does not have a uniform and definite composition or appearance throughout that mixture. Meaning there are different phases in this type of mixture. There are visibly some different parts there. You can see them. An example of that would be a salad. You can have lettuce, tomatoes, croutons, cheese, bacon bits. Whatever you have in your salad, you can see the different parts there. So that is not uniform. There's no definite composition there. Another example, salad dressing. Oftentimes we get salad dressings and we see that they're for Italian dressing. And for example, you can see there's a layer on top, a layer on the bottom. Oftentimes you have to shake it up in order to get it all to mix together, and then eventually it settles out again. So salad dressing, you have different phases within that dressing. And a Snickers bar. Of course, you have your chocolate phase, peanuts, caramel phase, and whatever else is inside of Snickers. You can clearly see the different parts of that Snickers. Now, just as homogeneous mixtures had different subcategories like solutions and colloids, heterogeneous mixtures have different categories as well. One in particular that I'm going to share with you is called a suspension. A suspension is a specific type of heterogeneous mixture. In a suspension, the particles are large and visible to the eye. These particles will settle out over time, and these particles can be separated through filtration. An example of this, if you've ever gone to the beach, is getting a bucket of sand and water. If you have a bucket or a bottle of sand and water, you can shake it up as much as you want, mix it up, but eventually those particles will settle down to the bottom of that particular container. So when this happens, we call that a suspension. These particles are very large, so large that we can see them with the naked eye. So if we're going to talk about particle size for a moment, suspensions or heterogeneous mixtures usually have the largest particle size. Then colloids, and the smallest would be particles inside of a solution. So gentlemen, please take notes on this. We'll talk more about this next class. Adios.